Yeah. So I was gonna say I'll share a screen but sharing screen is disabled by the host
Oh,
for some reason.
sorry. Let me figure out why. Okay. It should be available now.
All right, awesome. So, all right, so can you guys see my screen?
Yes.
Yep.
All right, so we have a bunch of PRs that were created over the last week. Well, yeah, three actually. There should be one for migrations that is also reviewed. So this one is Roxanne created it, which is, I'll quickly go, we discuss this. Is this the, it doesn't matter really. So we have one thing that's in review is to improve diagnostics for when we report errors around if FN once, FN mute, and FN closure, like the traits are not being met. So now we can provide better diagnostics in terms of just like the place that we report is now the precise path that's made us select FN once and whichever thing. Similar for when traits like copy trait is not met. We now report precise diagnostics. So PR is open for that. What else? I have a first PR open for migrations. So this is the basic, what we had discussed where we just use news drop to select places that might require, so just hold on, quickly scroll down. So this is just like a basic set of test cases based on news drop that might need migration. So this is done, and now we have this lint, which you can just enable, which is disjoint, deny, disjoint, capture, drop reorder. But again, if a name can be discussed and we can come up with a new one, but there's this that's open. We have a PR open from before the holidays, which is to fix, why does it not show me a related PR? Interesting. Okay, give me 1 second. I might have not tagged the issue, so hold on. This one, yes. So this is the one we were discussing where I have a hack in place to get around some of the diagnostic issues in the borrow checker code. I wasn't able to figure out where the issue was coming from.
I forgot about that. Yeah. Did you want some help to track that down?
Yes, I would like some help on this. I wasn't able to figure that out where that was coming from. Basically, when I started looking into debug logs, a lot of what I saw was borrow checker states. Yeah. So yeah, that's basically what's really outstanding on this PR. Chris has, I don't know if he created a PR in Rustlang, but I at least approved it on our end that initial work on splitting paths for borrow checkers, like we can now store more detailed information on basically separate the span for the path that we selected versus the span for the capture kind that we have so that we can do better diagnostics. So that is also there. So one thing I think that's important that I kind of want to discuss right now is what Tyson brought up recently about our destruction, the significant destructors that we were discussing for migrations before the holidays. So what we had talked about was like if a destructor is defined in standard library, we do not want to migrate for it because most likely all it's doing is cleaning up memory. But it is possible that there might be other side effects, like in their example over here.
Yeah. So I didn't mean to say that any type in the standard library, but
Okay.
more like select types that we choose.
Okay, that makes more sense then. All right. So that I'll start implementing. So needs drop today is implemented as a query. I'm wondering if you want to add another query for something like this, or how do you want, because then that means it will get into, like, if someone runs the lint at some point, the results from that query will get stored in some, I guess I'm assuming, incremental cache. So do we want to implement that as a query, or how do you want to go about that?
I think a query. I'm a little bit. I'm trying to think what kind of context it needs.
I'm assuming we just need to see what attributes are defined on a definition ID, because that's what really will come down to. So the type will have a definition ID and or something associated with it, and we can just look at the list of attributes on it. That's sort of where my head was at with how I'll implement it. So I can technically go and do it all myself, but I don't know why it's implemented as a, like, how there might, I'm assuming there's some things more complicated. That's why it's done the way
Oh,
it's done
I
today.
think needs drop is a query because it's good for it to be cached. It gets called a lot. Well, I guess what I was thinking about was, I'm trying to remember. I think we had planned, all you needed to for this new query was the type, right? The type that might be dropped.
The type that might be dropped, yes. But you need some way of looking at the attributes on that type, because that's how we'll annotate it. So
Yeah,
maybe
but
some
you
kind
can
of
get that
definition.
from the def ID.
Yeah.
Okay. Yeah, a query is probably good.
Okay.
The thing is, just thinking, the only challenge with the query will be, it doesn't have to be a query, I wouldn't say. And the only challenge would be that if it's going to recurse, which it will, you have to be careful about query cycles. And I'm not sure how needs drop handles that. I think it creates an internal vector to track it or something.
Okay.
And you have to look, but like the danger would be if you just naively, because needs drop will then recurse on the things that are contained within, right? And if you're naive about it, it'll get into a cycle and ice on, like, types that reference themselves.
I'm assuming, so if there is a cycle in needs drop, I'm assuming that's just incorrect behavior. Is that valid code that can have a cycle in it?
Oh, valid code for sure.
Okay.
So an example would be like, you might have a struct foo. Let's say you have a linked list. Okay, you have a struct linked list, and one of its fields is next option box of linked
Okay.
list.
So
Or something.
box.
There's
Okay,
like a
that's what I was
cycle.
thinking.
Yeah.
Yeah. Okay. That's what I was thinking. Box might be the way.
If you open up, if you want, I mean, we can look at the source now, but I'm sure needs drop has an internal stack that it uses to manage this or something.
I didn't look too much into the query itself, but yeah, it ends up being ends up calling a query. It was implemented in an interesting way. What else? Yeah, another thing we probably want to be careful about is generic arguments. So let's say we have a vector of whatever types. Now the vector will have vector will be a significant drop type if the elements within it have significant drop. So like if you have a vector of a type that the user implements that type and has a custom drop, then that vector now becomes significant to us because that drop order could have actual effects, like could have side effects other than just cleaning up memory.
Okay, so right. So the fact that, let's see, what you're saying here is, yeah, you can't stop the search when you find a type that
Yeah.
I think that seems right. You keep going, but if we go to what needs, I mean, in other words, vec of t, if you look, can you pull up the needs drop code? I think that would be helpful.
Sure. Give me 1 second.
Or I can do it. Although I'm on a new computer and I have yet to edit any code on this computer.
fine. I'll open from here. Hold
I
on.
did install VS Code, but haven't run it.
So this is the needs drop code, and it calls needs drop component. So bunch of this is
Yeah,
interesting.
okay. Perfect. What? Sorry.
So one thing that's interesting to me is why do we return this sort of small, like a two tuple essentially?
Yeah, so a small vec is just an memory optimization,
Yeah,
for performance
that,
optimization.
yeah.
What this does is it expands the component says, given a type, what are the types that type drops recursively? So like an int doesn't drop anything. A tuple drops its elements. A struct would drop its fields, and so on. Right.
I understand that, but I am missing the part where there's like this slot. Oh, it's a slice. Never mind. Of two things. I'm missing the part of this.
That's just how
Okay.
small vec works. Yeah. So if you scroll up now, where does this function get called?
So the function gets, this is needs drop component. So this gets called from here, which ends up calling this query somewhere over here.
Okay, so if you go into that needs drop raw.
Okay. I don't, yeah, it's not implemented here.
Yeah, I don't know where it's implemented.
It's one of this or the call above it is a query for sure. So where did it go? Sorry, hold on 1 second. And has sorry, I don't know why it's doing one. Okay, I think it's no. Just work, please. Sorry, I have no idea why this is being so slow. Okay, yes. So the attributes on this are.
Yeah, just go to the source. Yeah.
Oh, all right. I'll just go to the source. Oh, that's what jumps up there. I see.
Oh, come on. No.
All right.
Doesn't
It
know where the
just.
source is, does it?
I don't think it would. Yeah. So it's just like the
Yeah.
proc macro that will be behind it.
If you, okay. Well, it's not that important. I'm sure what that code looks like, if we could find it, is it basically has like a loop where
Like I get the idea of where how you basically do kind of a DFS or something. Just keep that
yeah,
idea.
right, exactly. And it must have a queue and
Right.
a hash set. And the main thing I'm trying to emphasize is that I'm sure what it doesn't do is call the needs drop raw query recursively on each of those components, because that would lead to cycles.
Okay. Yeah. My point was around asking about the vector stuff.
Right. All right. Oh, all right. So vectors, I forgot. What vectors will do, I mean, the way that would work is that the component of the vector will be t, right?
Oh, so that will be available as something. I see. That makes sense. I was thinking more around if we could just look at the substitution then a type because that will give a generic argument. So I was thinking, what do you think about that approach?
That doesn't work as well because it may or may not drop all of those arguments, for one thing. So like you could have a struct that has inside of it an ampersand t, in which case the t won't get dropped.
I see.
Also, yeah, so the needs drop code, like the needs drop components kind of already solves that problem essentially. The advantage of the scheme you're proposing would be that you wouldn't have to worry about cycles, but unfortunately it's not sufficiently precise. But I think if you look at how needs drop works, which I don't have in front of me because
I can open the previous one again. Like I have it here. Like the needs drop component. I think I know
yeah,
where
I
I
mean
can
the
find
needs
it.
drop raw implementation, but what I'm
I
sure
think I
it
know.
does, it kind of searches until it finds something that needs drop, right? And so I think basically something that has a destructor.
This code, the utilities code in type might be the one doing it.
I don't know. Oh yeah, maybe this click the needs drop raw function there. Yeah.
Okay, yeah. So this is the code that does it. I think this looks like.
Okay, okay, yeah. And you can see the stack and the hash set there.
Yeah.
Scene ties. So if you go down now, I don't know what that use size is for, but whatever. Keep going
Yes.
down. Keep going down a little bit more, a little bit more. Here, stop. Okay. So the ADT, that's
Okay, so that's what we do. We do look at the situations.
no, what's going on here? This doesn't look right. No, sorry, scroll up. It's not what I wanted. Keep going up. Stop. No. Where does it find? Somewhere
Wait,
here, somewhere. I'm looking for somewhere there must be some code that says like, yeah, yes, I found a thing that needs drop.
Oh,
Where is it?
I think something like this is the next part to it. Might be. So
Yeah, that looks right. Where does that get called?
so it that's when you drop raw is. So that just gets called on each of the fields in the ADT, I'm assuming.
Oh, okay. So ADT fields is like that's wacky. Okay, fine. I see. Yeah. So if you go back to that ADT drop ties, I don't know where exactly that's getting called, but the point is here where it says if there's a destructor, return error always requires drop.
Mhm.
Basically, I think all you need to do is change this to say if there's a destructor and it doesn't have this attribute
Yeah.
that says the destructor is a no-op, then
Yeah.
then
Yeah, I
return
think
drop.
this destructor, I think I looked at this function and that was essentially it will look at if the attribute was defined on the parent. Or sorry, drop was defined on the parent or something like that.
Yeah, I mean you can put the attribute.
Yeah, it's basically doing the same thing. Yes, looking
It's
at
only going
the
to be in the standard library, this attribute, right? So we can put it either on the struct or on the destructor or on the destructor impl, wherever you want it to be. Doesn't really matter. Putting it on the
Okay, that
struct
makes
might be easy because you have the def ID of the struct right there in your hand.
yeah.
But
Yes.
so, and then the idea would be that we basically run this lint, see how many, and see what false, I mean, either we go through all the structs in the standard library and decide where to put the attribute, or we run the lint on a bunch of code, and every time we get a false warning that seems silly, we add more attributes until we stop getting silly warnings.
Yeah.
Both
Basically.
will work.
Yeah, I also have the precision pass implemented that we talked about the step that would be after this. So let me, I don't know if I committed any test cases to that, but I think the idea for using a slice actually worked pretty well. I can show you that as well. One sec.
So you have some reviews pending for me. That was what we looked at
Yeah.
at the beginning, right?
Yes, we have some reviews pending.
I will try to catch up on those.
All right. Okay, yeah, this one. Yeah, so let's see. Yeah, so basically the slice setup that you were talking about actually worked very nicely. Yeah. One thing that was another interesting thing that I don't know if we discussed or not
Right.
was that it is possible that let's say we have a structure and we capture all of its fields like completely. It is still possible that the structure implements drop, in which case we would have to migrate. So
Yes.
yeah.
Yeah, that's a wacky thing.
Yeah, that was another That was an edge case. So yeah, that is done. So let's just go back to
I'm sorry,
the,
what does this do?
sorry,
Oh,
you're
this
fine.
has interesting drop outside of captures. Okay, I see.
Oh,
Yeah, cool.
yeah, so this is the helper function, which looks at like
This
basically
is
given,
go on.
sorry. So basically, so this is a helper function, so it's kind of written in that sort of very not reusable sort of format, I guess is probably the better way. But basically, okay, I'll walk you through the example, might be easier.
Hmm.
So we have this wrapper which has a point. Ignore the ampersand. I realize I didn't need that there, and it's wrong to actually have it here. So yeah, so we have this wrapper. We have a point and a color inside it. Color doesn't implement drop. Point has fancy integers which implements drop. And basically what we do is we capture w.p.x and w.c, which means w.p.y is in capture and we would have to migrate for it. Uh, Now the way we start is we start with the type of w and the slices of projections that represent our captures.
I see. Uh-huh.
Uh, Ignore the deref again here. That was,
Yeah, that's fine.
yeah. So we basically split into two parts. We now have,
Okay. Yeah,
we
yeah.
look at what starts at P, we start at C.
Yep.
Now we see that we have an empty slice in this vector, which means this thing was completely captured.
Yep.
So we don't need to deal with it and
Yep.
we return false. And
Yeah.
similarly over here, we see we have a slice which contains only one of them.
Yep.
But now that we are at P, we split into multiple parts. This one was completely captured, so we did do nothing. We didn't capture any path
Mhm,
starting at
mhm.
this, which would need to drop, and that
Yep.
worked out.
All right. This is great. Yeah, it's perfect.
Yeah.
When you expand in the any given node into its children, are you that's for every field in the struct or whatever, right?
That's in every field in the struct, every element in a tuple, yes.
Cool.
And
Perfect.
yeah,
Yeah.
so
Nice. Okay.
this, I tried a couple examples. This seems to work. We would need some of the previous PRs to go in just so that I can assert on a couple things, like it's
Sure.
not a raw pointer and stuff, but yeah.
Yeah. Are those all assigned to me?
Yes, they should be. I can go ping you on them, all of them again, if that is easier, or drop them on Zulip,
You know what?
whichever is.
Yeah, drop them on Zulip. I need to declare bankruptcy on my GitHub notifications. I will do that, and then at that point, pinging me would be useful again.
All right.
Otherwise, there's no point.
Okay. How long is this, a 1 hour meeting or is this like 30 minutes one?
I put in 1 hour.
Okay, I would like to get some idea on, and I can pull up my setup for the warning and maybe give me ideas on how I can debug this in some way if that is easier. But I can refresh you on the problem we have.
Yeah,
And
let's start with that. One thing that we could do, let me see if I have a build of this.
yeah, let me switch to this current. I haven't switched to this in a while.
I may. I have a bunch of stuff here. Polonius, no locations, all, nope. No.
So wait. Okay, yes. So the problem here was, and maybe test, I'll open another just to show the test file as well. Yeah. So the problem is, or like the thing we're trying to fix over here, oh God, is it a little bit? So we are modifying something used via an immutable. So like Z itself is immutable, but it contains a mutable borrow that allows us to actually modify the original place. Which yeah, which itself is immutable, but that's kind of the testing point. But the idea is we don't need Z to be mutable to fix our issue over here. The problem we run into is that we see an axis of the place Z, which is incorrect. We should only see an axis of place Z dot 0 dot 0 dot 0.
And do we know, and we don't know why we see that axis?
No, we don't. So basically, like where we do see this, like once I start backracing, it basically comes down to a function which is called from basically everywhere. And at some point I could not like none of the places I saw it being called from was directly near somewhere we reference upwards or like captures or anything. So it's kind of hard to figure out. And if I enable some more logging on it, I think I end up seeing a lot of bottle checker states, which to me did not make much sense.
Do you have, can you share a screen with like,
Code on for this?
yeah.
Yes.
Also, which PR is this? 80092.
I do not know.
I see it
But
right
yes,
there.
you're correct. 80092. Yes, that is the one.
Let me
Give me
get,
1 second.
I'm just going to check out the code.
Let me, how do I switch sharing screen? Okay, maybe I need to stop share and reshare. Okay, I think that looks about right. That's what I want to share. So, yeah. Okay, let me just commit whatever I was working on. Sorry, hold on a second. And I can just, I should really add another work tree on this. Okay, see if it's available, so that's not a problem. Yeah, sorry. I'll still go to these.
Okay.
While that switches the branch and stuff, we can still sort of look into where this gets called from. I have access. Sorry, report ability, I think. So yeah. So this is where it sort of ends up like we sort of start seeing the error. So this is the first place that we can like sort of sanely track where that is called from. So we want to make sure that we did not report a mutability error, but we end up. So this is like one of the locations. Sorry, I read the word location there, but like function calls where.
You know what? I'm thinking, yeah, I'm thinking it will work better. It's not to, maybe we can. Are you available later today?
I am.
I don't know about you, Roxanne, but what I was thinking is, what if I got this building? I think it'll work better if I can drive.
I think that would be a nicer.
And dump logs and so forth. But I think it's going to take me like 20 minutes to do that, you know, just like get my SSH set up and so on. And then I have a few meetings, but if I pinged you in the afternoon, would that work?
Yeah, ping me. Can you give me just an idea? Just so
Yeah,
that I know to
yeah.
check Zulip, but
Can I do that in a few minutes?
yeah, take your time. Like,
Then
yeah,
I can
I'll check.
probably looking at my calendar real fast, probably 2 p.m. would work.
Yeah, that should be fine. That should be totally fine.
Okay.
Yeah.
Roxanne, do you want me to add you to the invite?
Sure,
Also,
yeah.
Roxanne,
2 p.m.
okay.
should be fine for me too. Yeah, I realized I was like talking in the emptiness.
Were you muted or something?
Yeah.
Okay. Oh, you know what? Oh, bother. Annoying. Okay. I have too many calendars now. So many calendars. Not that one. That's not even. All right. Debug PR.
Actually, before we leave, I do have another question that I just realized. Give me 1 second. I'll find it.
Okay.
Well, I have the question. I'll find it here. Sorry. So I think some things we can improve a little bit more than my initial, like, I don't know if we want to do this as an initial implementation or go in more details here, but let me share my screen again. That makes more sense. So the way we kind of define a bit of our logic is we give priority to things we see first. So the first time we'll see the use of an immutable borrow is the place we'll say, okay, this is why we're doing an immutable borrow. And similarly, like first time we see the use of a particular path that made us choose that particular path. So like the first time we see the most ancestor path that ended up getting captured per se will be the one we say was the reason why we captured that path. So for example, in this piece of code we have, like, let's say within a closure, we have print p.x and then print p. We like based on our sort of the way we define our things, we'll see that, okay, it's an immutable borrow because of this, but we captured p because of the second line. I technically think that these should be unified, and which would sort of make sense.
Like, in other words, if the use, you have some choice about what to say about why you made it an immutable borrow, and we're not making a very good choice. Is kind of.
Yeah, it will come down to that. Yes.
Okay.
So like I'm not like I feel like logic behind this would be kind of simple, just saying that if the ancestor path has the same capture kind as yours, then just turn the capture kind also to be for the ancestor path. Now I think we should do this.
That sounds good.
Yeah. And
yeah, I think that's probably the right logic.
Okay. Yeah, so all right. Okay, just want to check that. We want to do that. All right, I'll ask Chris to fix that one as well before we push review then. All right. Yeah, I think that is it.
Okay.
Yeah.
Sounds good. Then I will get this environment set up and
all right.
invite you all to a meeting later on.
Sounds good.
I'll just add everybody to the invite who's on the other invite, if I can.
Let me just make sure I copy.
Yep. Oof, okay, sounds good. Talk to you all later then, I guess.
All right. All right, sounds good. Thank you.
Okay.
Bye.